Well, we have a gram per milliliter to begin with. Okay? And we will start with the quantity that we need to convert. So we have 1 gram per milliliter. How many sig fig? Just one. Measured quantity there. We want to convert, in the end, we want the density to be in pound per plot. So basically we need to go through conversion there so that we can convert gram into pound, milliliter into plot. You end up with pound per plot. Okay? So let's do 1 unit at a time. First, let's convert gram into pound. So this is the conversion factor you plug in. Remember, the gram is on top here. We have to cancel all the grams, so gram is going to be on the bottom there. And gram will cancel out. Okay? So that will give you pound per milliliter. We're not quite there yet. We need pound per plot. Okay? Now we need to convert milliliter to liters. Okay? So in this case, 1,000 milliliter is equivalent to 1 liter. When you do the multiplication there and say, I probably shouldn't have said that, so always put the unit you don't want on the, well, it's not always on the denominator. It's always going to be, you need to watch for the unit you don't want has to be able to cancel out. In this case, 1 gram per milliliter, the unit milliliter is in the denominator. So if you try to multiply a conversion factor, cancel out the milliliter you don't want, then the milliliter has to be in the numerator. So in this case, if you do this calculation, milliliter will cancel out. Second step. Now we have pound per liter. That's still not what the question is asking you. You need to figure out 1 liter, 1.057. Oh. Here, liter and liter cancels out. Now comes the easy part. 1 divided by 453.6 times 1,000 divided by 1.057. Punch number in the calculator, you can do that easily. Okay. You end up with 2.0857. Sig fig, 1 sig fig, rounded out to roughly about 2 pounds per plot. That's going to be an answer. So the first question, the first exercise that we did, aspirin pound to gram, we just need 1 conversion factor, single step. And the second conversion, inches to meter, we gotta have 2 conversion factors involved, 2 steps. In this particular question, 1, 2, 3, we got 3 conversion factors. So it takes the basic format is steps. All we need to do when we do conversion here, all we need to do is to identify the conversion factor. Once you identify the correct conversion factor, the rest of it is easy. Watch for the unit, cancel out the things you don't want, end up with the things you do want. So this particular example involves 3 conversion factors. And things can get even more complicated. So the answer is, again, when you get the answer there, you have to pay attention to the sig fig and to the unit. You have to report sig fig, correct number of sig fig, and the correct unit. Or when you give me the when you turn in the work, when you're reporting your result there. Okay. So a practical application, something that you will be doing in the laboratory tomorrow. We ask you to determine the density of a piece of metal by using what we call water displacement method. So you have a graduate cylinder, you put some water in there, okay? You get the reading of the water, volume of the water. Now you take the object, you drop it in there. Of course, you know, if you have a bathtub full of water, you step in, the water will overflow. So the same thing happens here. If you have a certain amount of water in the graduate cylinder, you drop something in there, the volume will increase. Now the volume of the water being displaced, in this case, as long as the object is completely submerged, the volume increase equals to, in water, volume increase in the volume reading for water between before and after, well, the difference is the volume of the object we put in there. So in this case, we say a mass of metal weighs 74.122 grams. Okay, and it goes from 28.2 milliliter, that's the original water level, After you drop the metal in, it goes to 36.7 metal. The difference between these two will give you the volume. Now, the question we ask you to calculate the density of this piece of metal. Density equals to volume divided by mass, right? Mass divided by volume. I guarantee you, someone, when we ask you this question there, I will see someone doing volume divided by mass, calculating density. Trust me, I will put that answer as one of the choices in the multiple choice. And someone will also count, hey, there's an answer there. It matches my answer, must be the correct. Now, you have to know how we define density. Density is mass over volume. Mass is given. Volume, we can figure it out. Okay, sig fig. How do we determine the sig fig? You are doing subtraction between these two numbers there. Okay? So you should keep the one decimal place. These number of decimal places, because each one only has one decimal place there. So 36.7 minus 28.2, you end up with 8.5 milliliters. This is going to be the volume. This volume, the reading of the volume only has 2 sig fig. Mass divided by volume, how many sig fig are you going to keep? Mass has 5 sig fig. Volume has 2 sig fig. You do the division, you go with the least number of decimal places, or the sig fig. Least number of sig fig. So you go with 2 sig fig. Those are the rules that you have to remember, and you remember those rules through practice. So make sure you take the time to do your homework there. So for this particular question there, what is the density of the metal there? Well, we need you to use the correct number of sig fig in your answer, and we have 74.122 gram divided by 8.5 milliliter. I will give you 8.7202. And that's what the calculator tells you. And 2 sig fig, so 8.7 gram per milliliter. Okay. So again, when you report the result, pay attention to the sig fig. Pay attention to the unit. A number without unit is meaningless. You have to focus. You have to pay attention to those things there and focus on those 2 factors there. You can't go wrong. Another exercise. Why do we need to measure density? Sometimes you ask these questions. When you learn math and you ask, why do I need to know calculus? Am I ever going to use it in my life? Probably not. So math is sometimes quite abstract. But chemistry is more interesting. I say that because I'm a chemist. If I'm a mathematician, I'll probably say different things. However, we do have an application. We can actually use density to identify a particular subject. Say, suppose you have a piece of solid, looks like gold, but you suspect, by taking the mass and measuring the mass and then trying to estimate the weight there, it doesn't seem like gold. How do you know whether this piece of metal is gold or not? Well, we can measure the density. We know gold, well, you can find this information in pretty much a lot of different resources there. You can find information there. My generation, I go to the library, they're actually use the CRC handbook, and that's thick like a brick there. Now these days you have your smartphone, density of gold, Google will tell you 19.3 grams. So this particular question there is solid. If you put this piece of solid metal there and it looks like gold there, you want to determine whether or not it is gold,